Hello friends, welcome to the online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. V.R. Vadekar from the Department of Electronics and Telecommunication from Matoshi College of Engineering and Research Center, Nasik. Guys, we have started with unit number 2, that is error detection, correction and data link control. So let's start with our today's lecture. Now students, today we are going to discuss about the types of protocols. Then we are going to discuss the protocols which comes under noiseless channel protocol and one protocol that comes under noisy channel protocol. But before that, let's have a quick revision. So students, if you remember, we have started with data link control services as like your framing, error control, flow control. In framing, we have seen the fixed size framing, variable size, what is character oriented approach, what is byte stuffing, what is bit oriented approach, bit stuffing. Then we came to know about this flow control and about error control. So let's start with our today's topic. Now guys, the data link layer, it can combine framing, flow control, error control to achieve the delivery of the data from one node to another. And the protocols are normally implemented in software by using programming languages. So these are the protocols. So on the screen you can see it. Protocols basically it is classified as for noiseless channel and for noisy channel. For noiseless channel, there are two types of protocols, simplest protocols and stop and wait protocols. Whereas for noisy channel, there are three types of protocols, stop and wait ARQ, that is automatic repeat request, go back and ARQ, and selective repeat ARQ. Now you would wondering that what is this noiseless channel and what is this noisy channel? So let's clear this doubt. So basically, let us first assume guys that we have an ideal channel in which no frames are lost, no frames are duplicated, or even no frames are corrupted. So such type of channel, it is called noiseless channels. So as we know, the two types of protocols that we are going to discuss under this category, it is your simplest protocol and stop and wait protocol. So let's start with this simplest protocol. Now guys, in simplest protocol, basically as the name suggests, it is very simple kind of protocol. In this, the sender, it is going to send a sequence of frames without even thinking of the receiver, because it knows that frames, it is easily going to reach to the receiver because we have assumed it is what? Ideal channel, noiseless channel. Now, to send 3 frames, 3 events occurs at the sender side and 3 events at the receiver side. And you can see from this figure 1.6 that sender A, it is going to send the frame without even thinking of the receiver whether it is getting or not, because it is must that the receiver must get the frame without any corruption, without any loss, because we have assumed channel is noiseless. Similarly, there are many frames it has been sent by this sender to this receiver. Now guys, now you can observe this height of this tilted box. See this one. So this height, basically, it is going to tell you what? It is going to tell you the transmission time difference between the first bit and the last bit in the frame. So please note that. So such type of protocol, it is called a simple protocol. Hope so you understood this protocol. Now guys, moving towards next protocol, that is stop and wait protocol. It is also very simple, but there is a difference. What is the difference? That sender, it is going to sense one frame and then it is going to wait for the feedback from the receiver. So feedback, it is going to come in the form of your ACK frame that I give the clue about this ACK frame in our first lecture. And then sender, it is going to the send the next frame. So you can see it in stop and wait protocol. For sender, it is going to send the frame, and until or unless the acknowledgement it is being received, it is not being received, the sender, it is not going to send the next frame. As soon as the acknowledgement from the receiver, it has been arrived at the sender, then and only then the sender, it is going to send this second frame, and this process, it continues. After sending the second frame, again sender, it is waiting for the feedback, it is waiting for the acknowledgement, and when this ACK frames, it means it comes, it tells the sender that the frame that you have transmitted, it is received by the receiver without any corruption or without any loss. It means it gives you the positive acknowledgement. Now guys, we discuss about what? Noiseless channel. So now, what is noisy channel? So basically, noiseless channel, it does not exist. Noisy channel in the sense what? There is a scenario that there may be a chances of getting those packets or frames that to be corrupted, that to be lost. So we need to retransmit those frames in that scenario. And in our practical life, all the channel, it is what? Noisy channel. And as you can see on the screen, the three types of protocols, it comes under noisy channel. First is stop and wait automatic repeat request, ARQ. Second is go back and ARQ. And third is selective repeat ARQ. So for today's lecture, guys, we are going to discuss first protocol, that is stop and wait ARQ. Now guys, error correction in stop and wait ARQ is done by keeping a copy of the sent frame and retransmitting of the frame when the timer expires. So basically, in this guys, there is a difference that as compared to stop and wait protocol, in stop and wait ARQ, we are going to use a timer. Right? As like, suppose if I am going to ask you whether you are getting the lecture, if the response, it is not coming from the students, then I think that I need to redeliver the lecture. Right? I am waiting for your acknowledgement, whether you have understood the lecture or not. But suppose within a particular time, if the positive response that is coming from the students that you are getting the lecture, then I came to know that whatever the content I delivered, it is reached to the students. Now it's time to deliver the next topic. So it's like that one. So guys, in stop and wait ARQ, we use the sequence numbers to number the frames. But to number the frames, we are going to use a modulo 2 arithmetic. It means what? If suppose first frame, it is given the sequence number 0, then the next frame, it is what? Given the sequence number 1. Similarly, the third frame, so can anybody tell what would be the sequence number for the third frame? The third frame sequence number, it would be 0, because the sequence numbers are based on modulo 2 arithmetic. So similarly, for the fourth frame, it would be sequence number 1. So it means 0, 1, 0, 1, 0, 1. This is going to repeat in stop and wait ARQ. Also, in stop and wait ARQ, the acknowledgement number always announces in modulo 2 arithmetic the the sequence number of the next frame expected. That is, I am going to tell you when I'll show you the figure. So let's start with a first figure. In this one, the frame 0, it is sent an acknowledgement. Simple, guys. So see this frame, this is a sender and this is a receiver. Now this is Sn, it is a variable. It is going to tell you the sequence number of the frame that to be sent at the sender side. And you would get, there is a variable called Rn which is going to send you, which is going to indicate what the frame that to be received, that is being expected. So you know the difference is that in stop and wait ARQ, the timer operation it is there. So as soon as the frame 0 it is being sent, the timer it has been started there, right? So when this frame 0 it is reached to the receiver, you can see that one Rn over here it is a 1. So it is going to send the ACK1. ACK1, it is a positive acknowledgement. When this ACK1 it is reached to the sender, then sender it comes to know that frame 0 it has been reached properly. Now I need to send the next frame, and this next frame, that is ACK1, that is a frame 1. So SNN it increments by 1, and as soon as this ACK1 it has been arrived over here, the timer it gets stops, right? So it is very simple. Frame 0 it is being sent and it is acknowledged. So what I told, the acknowledgement number always announces in modulo 2 arithmetic the sequence number of the next frame expected, right? So instead of ACK0, ACK1 it is here. It means frame 0 is being received. Now I expect frame 1, next frame. Now in the same scenario, if suppose frame 1 is lost and resent after the timeout, then the resend frame 1 is acknowledged and the timer stops. So let's see the figure. Now guys, as already been told that frame 1 it is being sent, but you can observe that the timer it started, but the frame 1 it is being lost, right? So if the timeout it is there, because no acknowledgement it has been received, the timeout it happened, then the sender it is going to think that somewhere my frame it is being lost or corrupted, so I need to resend the frame. So after timeout period, this frame is resend. See, the frame 1 it is what? Resend. And as soon as this frame 1 it is being reached over here, the Rn it increments to 0. Now it sends ACK0. So as soon as this ACK0 it get received, the timer it gets stops. It means the sender come to know ACK0 means what? That frame 1 it has been received properly by the receiver, and now the next frame, that is frame 0, I need to send it to the receiver. Now in the same diagram, let's have a third scenario. What is the third scenario? Suppose this frame 0 it is being sent an acknowledgement, but what happened? This acknowledgement is lost, guys. So the sender it has no idea if the frame or the acknowledgement is lost. So after the timeout, it is going to resend the frame 0 which is being acknowledged. So let's understand this scenario by this example. So you can see that frame 0 it has been sent, the timer it is being started over there. As soon as this frame 0 it is being reached, you can see this Rn increments to 1. Why is it so? Because frame 0 it is received. Now the receiver expect frame 1, so that it is going to send what? ACK1. Now after sending ACK1, you can see on the figure that this acknowledgement ACK1 it is being what? It is lost. So guys, Timeout period, it happened. Sender has no idea if the frame or the acknowledgement it is lost. Then what is going to be happen in this scenario? Frame 0, see the earlier frame 0, it is being resent again, right? And similarly, the timer it restarts at this instant. But guys, as soon as this frame 0 it is reached at the receiver, Rn equal to 1, right? But what is the frame it came? Frame 0. So then receiver would come to know this frame 0, it is what? It is a duplicate frame because I already got the frame over here. But the sender has resent the same frame again. So it is going to discard this frame. Again, this receiver, it is going to send this ACK1 again, so that as soon as this ACK, when it is received by the sender, the timer it stops. And then after this timeout period, this frame 0 it is being acknowledged. Then the sender comes to know that frame 0 it is being sent. Now I need to send what? Frame 1. So whatever the three scenarios that we discuss, it is that overall this scenario. So in the first scenario, you can observe it. It is a quite simple. Frame 0 it is being sent and it is acknowledged. In second scenario, we have taken the acknowledged example of frame it is being lost, right? And in the third scenario, we have taken the example of acknowledgement is being lost. So you have the three scenarios and we have explained this one. So hope so you understood these three scenarios. Now guys, assume that in stop and wait ARQ system, the bandwidth of the line it is 1 Mbps and one bit it takes approximate 20 milliseconds to make a round trip time. So guys, it's time to take out your notebook and pen, and please, this is a numerical. So please, along with this, you also write this and let's solve with me. Round trip trip, it means what? When the frame it is sent from the sender to the receiver and the acknowledgement it is being received by the receiver to the sender. It is sent by the receiver to the sender. What is the total time duration? It is called what? Round trip time. So the bandwidth of the line it is what? 1 Mbps and one bit approximate it takes what? 20 milliseconds. So you have to calculate guys that what is the bandwidth delay product. This is the first part. In second part, suppose if the system data frames are 1000 bits in length, it means what? The length of the frame it is what? 1000 bits. Then what is the utilization percentage of the link? So you have to find out these two values. First it is your bandwidth delay product and second it is your utilization percentage of the link. So let's start with this bandwidth delay product. So as the name suggests guys, the bandwidth and the delay product, it means you have to make a product of this bandwidth as well as this delay. So it's quite simple. 1 MB, M capital M, it means a mega, that is a 10 raised to 6. So 1 into 10 raised to 6 product with what? 20 milliseconds, that is 20 to 10 raised to minus 3. So what is the answer? It is what? 20,000 bits. So you can solve it and if you will get the answer is what? 20,000 bits. Now, you need to find the utilization percentage of the link. So guys, suppose the system, it is can send a 20,000 bits during the time it takes for the data to go from the sender to the receiver and then back again. We have calculated from this bandwidth delay product. The system, it can send what? 20,000 bits. But however, the system sends only what? 1000 bits. So what is the link utilization, guys? It is 1000 divided by 20,000. It means what? Only the 5%. So you can see this. So for this reason, guys, for a link with a high bandwidth or long delay, the use of stop and wait ARQ, it is going to waste the capacity of the link. Although it has a capability of 20,000 bits, but the frame which consists of 1,000 bits. So what is the link utilization? It is 1000 by 20,000. That is only 5%. Now next example, what is the utilization percentage of the link in our previous example if we have a protocol that can send up to 15 frames before stopping and worrying about the acknowledgement? It means what it wants to tell, that in earlier example, guys, we have sent one frame and then we are waiting for the acknowledgement. But now what we are going to do it, instead of waiting for acknowledgement after sending one frame, now we can send up to 15 frames, right, before stopping and worrying about the acknowledgement. So what would be the solution? Now as we know, guys, that the bandwidth delay product is still what? 20,000, and we know that one frame consists of 1,000 bits, then 15 frame, it consists of what? 15,000 bits. It means what is the utilization? It is a 15,000 divided by 20,000. That is 75%. Right? But of course, guys, out of these, 15,000 bits or 15 frames, if there are damaged frames, the utilization percentage, it is much less because the frames have to reset. But you can observe this one, that earlier it was what? 5% only. But now this utilization of this link, it is much increased to what? 75%. So guys, in this lecture, we have seen about the protocols. Protocols for noisy channel and for noiseless channel. Today we have discussed noiseless channel. Noiseless in the sense where there is a no loss of frames, no corruption of frames. The data, it is being sent by the sender to the receiver and it is being received very accurately and with high degree of accuracy. In this, we have seen two protocols, simple protocol and stop and wait protocol. In simple protocol, the sender, it is continuously, it is going to send the frames without even thinking of the flow control or error control because it's ideal channel. And in stop and wait protocol, we have seen that one frame it is being sent and then sender, it is waiting for the acknowledgement. And after receiving the acknowledgement by the receiver, then sender, it is going to send its next frame and this process goes on. But guys, this noiseless channel, it does not exist. So that's why it is needed to design some protocols for noisy channels. Noisy channels, it means what? Where the data or frames, it could be lost, it could be corrupted. So in that scenario, we need to retransmit those frames. For that, sender needs to keep the copy of those send frame. And we have seen the three protocols, it comes under this, noisy channel. That is your stop and wait ARQ, go back and ARQ, and selective repeat ARQ. And out of these three protocols, we discuss one protocol, that is stop and wait ARQ. So in that, we have seen three scenarios. One, the data it is being sent without any error, acknowledgement it is being received. And in next scenario we have seen that frame it has been lost, so how this process it happens. And in third scenario we have seen when the acknowledgement it is lost, how is the scenario. So it's all about our today's lecture. So this is the assignment that you need to solve it. So please note down this assignment. In next module, guys, we are going to discuss about, sorry for this change. In next topic module, we are going to see the second protocol, that is go back ARQ. This is my email address. So you need to submit those assignment to my email address shown on the screen. So thank you very much, students, for today's lecture. We would meet in next lecture.